Okay, so what do we do once we find the gradient of the Perlin noise? Let's say we have found G as explained before. Now, let's remember, what does this represent? This represents a vector on the tangent plane of the surface. So actually this vector is on this plane. Okay, this vector is on the tangent plane. But gradient is not on the tangent plane. So this, in the case of Perlin noise, what this corresponds to is, this is actually the projection of the gradient on the tangent plane. Okay, so if you project this gradient on the tangent plane, okay, so this is what this vector represents. Now if you connect this to the axis here, okay, if you connect this like that, so this quantity here, let me use a different color for that. This quantity, this distance is du, okay, du, and this distance is dv. Okay, so we compute the gradient first, and then we project it onto the tangent plane. Okay, so this is the gradient. Let's write it here: gradient projected on the tangent plane. Okay, so how can we perform this projection? There are several ways we can compute this projection. So let's say, let's use a different color for that. So let's say we have this component. Okay, so let's call this this is the G. Okay, let's say G orthogonal, and let's call this one G parallel. Okay, so we can see that G is equal to G parallel plus G orthogonal. Okay, so how can we then find G parallel? G parallel is equal to G minus, sorry, G orthogonal is equal to G minus G parallel. Okay, and how do we find G parallel? So G parallel is basically how much G goes along N. We can use dot product for that. So we can say G parallel is equal to G dot N. Okay, G dot N. G dot N gives us a number, and this number indicates this distance. Okay, but G parallel must be a vector, so along the normal vector. Okay, so to repeat, we first find the gradient of the Perlin noise function. Then we project this gradient onto the tangent plane. This represents the vector that we will use to perturb the original surface normal. Okay, and the projected gradient can be found from simple vector algebra. Okay, so the full gradient is the sum of gradient parallel plus gradient perpendicular. Gradient perpendicular is therefore original gradient minus gradient parallel, and the gradient parallel component of the gradient can be found as by using the dot product of G and N, and this parallel is along the surface normal. So we multiply it with the surface normal to make it a vector.